Hi, in this video, we'll take a look at a slightly more complicated version of the combinations of the options, which is called a butterfly spread. It is constructed by going long on a call at a price, at a K1, the first strike price, and going short on two calls at the second strike price, K2, and going long on a call at the third strike price, K3, where K2 is actually the middle point of K1 and K3 being the largest and K1 being the smallest. Okay, so again, let's take a look at the individual payoffs for these three different options. Okay, so for the first one, let's take a look when your ST is less than K1. So if ST is less than K1, so basically nothing happens, because for these two options that we have just bought, with the long position, we will never exercise it. So this will give us 0. Okay, there will be 0 payoff. And for the call options that we have just shorted, the buyer of these two call options will not exercise it if ST is less than K1. So for us, we will be making a profit because we have sold them the calls, but now we're just taking a look at the intrinsic payoffs. So that'll be just 0. Okay, and then if ST is somewhere between K2 and K1, we will exercise the first call option over here. So we'll get a payoff of ST minus K1. The other two does not change, so still 0 and 0. And in the third case, where we have K2 is less than ST and is less than K3, we'll still exercise the first option, because now your ST is far greater than K1, your first strike price. And here you would have a payoff of 2 times K2 minus ST, because now the buyers of these two calls will actually exercise it. So we'll be getting the opposite of the payoff. So it's not ST minus K2, but K2 minus ST here. And since we're selling 2 calls, it will be doubled here. So 2 times K2 minus ST. But for the third one, we're still not going to exercise it. And if your ST here in the last situation is greater than K3, we'll exercise the first, as always, here. That is minus K1. And here, the buyers of our 2 calls will still exercise it. So K2 minus ST, but then doubled, 2 times that. And now we're going to exercise the third call option, which is at the strike price of K3. So the payoff is going to be ST minus K3. Okay, so these will be the individual payoffs that we get over here. Okay, so what about the overall payoffs that we have? So take a look at the total payoff. So not factoring in the costs and also the profit that we have just made from or the revenue we have just made from selling the calls. We're just taking a look at the intrinsic values here. So if ST is less than K1, we would have 0 payoff. If ST is between K1 and K2, we'll still have ST minus K1 in this case. And if it's between K2 and K3, we would have these two together. Okay, we would have these two together, but then we can somehow simplify this but just a little bit by using this thing. 2 times K2 is K1 and K3. So we can write it out step by step. Let's just extend it over here. So that's ST minus K1 plus 2 times K2 minus 2 ST over here. Okay, so for ST here, we're going to be left with only 1 ST, and it's going to be negative. So there's something minus ST over here. Okay, so there's an ST. But for minus K1 plus 2K2, it's exactly K3. We're just going to move this into the left-hand side. So 2K2 minus K1 is exactly K3, which is exactly what we have over here. So that's just K3 minus ST. So we can write K3 minus ST here. All right. So for the last bit here, again, we'll just have to kind of expand it and collect every term over here. So that's going to be st minus k1 plus 2 times k2 minus st, and then plus st minus k3. Okay, let's open up the brackets and we'll see it's going to be st minus k1 plus 2 times k2 minus 2 times st plus st minus k3. So all the st's will be cancelled out. Okay, so you have 2 over here minus 2 over here, so they'll be cancelled out, and we're left with 2k2 minus k1 minus k3, and we have it here. K1 plus k3 is exactly k2, and we can sort of combine these two, and we have 0 over here because this part is exactly 2 times k2. Okay, so here we have 0 payoff, right? So it would seem that we're only getting a positive payoff when the st is between k1 and k3. So we can now draw the diagram for the payoffs here. Okay, so we can draw it one by one, but we can also draw everything on a single diagram. Okay, so let's just draw something like this. Okay, and this will be the payoff, and this will be our st, and this will be the net payoff. This time we'll consider the costs of buying and selling as well. So first we would have k1 over here, and let's suppose k2 is here, and then k3 is here. Okay, so for our first operation here, we bought a call option at k1, so let's just draw the net payoff for the first one. Okay, so we'll use probably a different color. Okay, well, we'll still use this color, but here that's going to be the first payoff. Okay, and then we sold 2 calls at k2, so that's going to be the opposite direction, but since we're selling 2 of them, the slope of our payoff will be doubled as well. Okay, not considering the flat part of it. Okay, we'll use another over here. So it goes like this. Okay, let's try to make it flat, and then it goes down by a higher slope. Okay, and finally we have another call, and it's at k3. Okay, so we'll use yet another over here. Okay, it's not flat, but we'll try again. Here. Okay, so that will be our overall payoff for all 3 operations combined. But what is the total payoff in this case, right? So here we can see before k1, we're getting 0 intrinsic payoff, which means we're just going to receive whatever these are added up to, right? So it's going to be here, right? So I'm just giving you the conclusion here. So we'll try to use another color as well. Perhaps let's use the yellow line or the orange line. So it's going to be here. Actually, let's make it bold over here. Okay, so this will be the first net payoff over here, and then after k1, we would have st minus k1 as our payoff. So we would have this. And then after k2, we would have k3 minus st. So we'll go back again down here, and then we'll continue with the flat line. Okay, so the orange line here is the actual payoff in total, and this is how we construct a butterfly spread. Okay, so as as we can see, why do we need a butterfly spread as opposed to like a straddle? So this is kind of the opposite of a straddle. Why? We're basically betting on stability. So if the underlying stock or the underlying assets price is not very volatile and it's just fluctuating somewhere between K1 and K3, and this will be our judgment, right? This will be depending on our own judgment, what range would it be? And if it's just fluctuating over here, we can make a profit. Yeah, so it does not matter which direction as long as it's not too volatile. But if it's very volatile, if it's extremely volatile, whether it's just decreasing or increasing in price, we will not make a profit, right? Because our overall profit will go negative because of the costs we have just used, because of the costs we have paid on the long positions. Okay, so this will be the overall payoff of your butterfly spread, and we're essentially betting on stability of our underlying asset. So as we have seen, you can construct whatever combination you'd like to just achieve your own goal, as long as you have access to the relevant derivative or the relevant options. So there are infinitely many combinations that you can think of, and you can combine them to a very complex degree. And of course, there are other types of options that you can use as well, but we're just using the simple options like call options and put options to make an example, okay, for an illustration. So it is sometimes likely that you will run into questions or exam questions, just like this one. So sometimes you'll be asked to provide an example when the investor is looking for profit and betting on stability or betting on volatility. So you can always use the straddle or the butterfly spread to achieve the investor's goals. And sometimes if it's more complicated or more complex in the exams, you might be asked to construct your brand new combination of the options to achieve a very specific goal, and that's going to be dependent on the case. Okay, so what we have done here is that we need to know the individual payoffs, and then we'll try to match our requirements for the investment. Okay, and I'll see you in the next video.